Hello and welcome to the fifth video in this BiteSize Pandas series. So this video is carrying directly on from the last video, doing stuff, creating new columns on data frames. You'll see here that I've got already loaded, locked and loaded, ready to go, the animals data frame. And I want to get a little bit more complicated now and show you some of the other techniques that are usually used when creating new columns on data frames. Those will involve three things. One will be list comprehension, which is a standard feature of Python, which you can look at online. The other one will be using anonymous functions, so lambda functions. I'll give you a small example of that. And then actually writing a complete custom function and applying that also to a data frame to calculate values for a column. And that should then really cover, with the last video, almost everything you'll need to do, or 95% of the things you'll probably need to do with your data frames and creating new columns. So the first thing is, let's make a new column. It's completely useless, but let's do it anyway. And let's make a new column where we can, let's just call it short name, like so. And I want to make a short version of the animal name. So data frame animals, animal, and I can't spell. Now, here what I want to do is I just want to take all but the last two letters of each name in animal, which means I need to take each string instance of the value in that particular series, and then I can use the standard indexing of Python to do this. So if I execute this line here, and you're familiar with Python, then it won't be any surprise to have a new column, short name, with the first letters of each animal name excluding the last two. So we've got P and C for pig and cat, and SHE for sheep. So we've lost the E and the P on the end there. And that's pretty straightforward, and what we did, almost what we did in the last video, apart from this little bit here. I can do the same thing using list comprehension. Now you might ask why I want to do that if it's going to look a little bit more complicated than what I just did. Well, the reason is you'll need to use, once you start, and we'll see in the next example doing more complicated stuff, more often you'll need to use list comprehension on the particular series that you want to use to get the values for your new column. So in this case, the way we'll do it, I'm going to say that for x in, and then I want my data frame animals, and I want my animal column again. So x is now representing each of the values in my animal series or animal column. And here I simply want to return the result, which will be x and then colon -2. And that will then create exactly what happened before. I'll just execute line 48 there to recreate our data frame. Run ahead on this. We haven't got the short name column. And now just execute this. Rerun the head, and you can see that we've got the short name column on in exactly the same way. The difference being is that we've used list comprehension. Another example of a classic use of list comprehension would be, let's say we want to make a column where we want to have true or false depending on whether the age is 15, greater than or equal to 15 or not. False if it's not, true if it is. And for this we need list comprehension. So I'm just going to copy this and say, let's call it over 15. Should be over 14 technically, but it doesn't matter. And now we want list comprehension. Again, I'm just going to copy this, except this bit will change here. We're still doing for x in data frame animals, this time age. So x will represent each of our ages. And now what I want to say is I want to give the value true if x is greater than or equal to, well, let's say greater than 14. So we'll change the column name to over 14, otherwise my tiny brain won't cope. So true if x is greater than 14, else, and we always need to give an else, false. The value is false by default. And now what we'll have on here, if I just execute the head again, is we'll now have a new column called over 14, where the sheep is false, but the pig and the cat are true. I'll just do 10 of those just to make sure we're okay. And we can see here in every instance that the age is over 14, we've got the value true inside here, so that's worked out quite nicely. And these two sort of syntaxes here are the ones that you'll come across, or you'll need most frequently, I would say, when doing list comprehension. We can also apply anonymous functions, so lambda functions, as we need to the values on columns in a column to create a new column. An easy example of this, again, it's a bit of a useless example. Let's imagine that we want to fill create a new column where we z-fill, so we fill all of the short names up to 9 characters with a 0 using z-fill. And the way we do this then, I'm going to call this new column zfill, so we don't lose track of what it is. And here I just need to say data frame animals, and then take the short name column. And then the crucial thing is to say I want to apply to that particular column, and now I can just write my lambda function. I was worried then for a moment, and here I want x.zfill, and also don't forget the line. And now that will apply this anonymous function to all of the values one by one inside short name and make me a new column there, a new series with zfill, this time everything filled. And again, I'm showing you these not to be particularly useful in this case, but more to give you the general techniques that I've seen people normally wanting. So these two syntaxes for this comprehension, and then here's applying an anonymous function. What if we want to do something a lot more complicated, and we want to do something to, let's say, let's do something ridiculous. Let's say I want a new column, and for each value in that, I want to, if the age of the animal is, let's say, less than or equal to 12, I want the name of that animal reversed plus the short name. Otherwise, I just want the value no thanks, or couldn't do it, or something like this. How would I do this? Well, this is now getting more complicated because the moment we've just been using values from single series or columns, now I want to use values from lots of columns. So the way I have to do this is actually write my own custom function for this. So I'll call this reverse name and take in my row in my data frame as an argument. And now I'm going to say that if my row and then age, and let's say is less than or equal to 12, then I'm going to do some damage to it. So I'm going to return for my new value the row animal value, but this row animal value, I said that I then wanted to reverse the name. So colon -1 should reverse that, and then I'm going to add on, I don't know why I decided to do this, but the row short name as well. Otherwise, if the age didn't conform to that, then I'm just going to return too old, let's say. And that's then my function here. So what I want to do is create a column where every value in that column will respond to the logic inside this function. So to do that then, I'll make a new column. I'll call it logic or logical. It isn't really, it's slightly ironic. And what I need to do here is just hit the data frame, apply, and the first thing I need to do here is name the function that I'm actually applying. And now critically I need to specify the axis. If I specify, and I need to specify that as 1, if I specify the axis as 0, this function reverse name will be called, and the argument row will be one by one each of the series or columns that I have here in my data frame. I want it, and that's axis 0. I want it to be axis 1, so I want it to give it me row by row. So therefore I do axis 1. And what that will do now is for each of the rows we'll create a column logical and insert, using the logic of reverse name, the values according to my function. So I execute that function, and now if we have a look at the result here, you can see that we've got sheep reversed and then SAG, then too old, and if I just do head 10 just to make sure that everything's looking okay, I could take cats, so cats reversed TAC, and then the C's been added on, and here we've got something that's 20 years old, it's too old, 13's too old, 17 too old. So it looks like it's worked out fine and as we wanted. So that kind of completes the little bit on columns. We've looked at adding columns, deleting columns, renaming columns, and also creating new columns, and particularly creating new columns using some kind of customization, which is something I know that is very frequently asked and required. So if you've got any doubts or any problems or something wasn't clear, then please feel free to leave me a comment. Otherwise, thanks for watching and see you in the next video.